All right, in this video, let's take a look at topic number 26, graphing linear inequality. So we've been doing a lot of graphing in this class. So the very last thing I want to show you is how to graph using inequality instead of equal sign. So graphing linear inequalities means we are looking for a specific region of coordinates that will satisfy the inequality. So that region is actually called the visible region. So when on the homework, when you do the handwritten part, if you see a less than or greater than, you can use a dash line. With the equal to, make sure you use a solid line. Okay. So the way how we're doing this, depends on which side, where is the region to be. It will all depend on the slope of the line. So for example, if I have an equation of the line going this direction, okay, all right, going this direction from left to the right means the slope is actually positive. All right, so we normally read the line from left to the right. So if it says greater than means above. So if you put yourself on the left side, the side where you at is going to be above. Okay, the side where you at is above. The side of the line that's below you is going to be below the line. All right. So if I have a linear equation or inequality where my line is going down the hill, so from left to the right, if I put myself on the left side, I'm going down the hill. So the slope M is negative, right? So the side where you at is always going to be above. Below you, that side of the line is going to be below. The only time we say right and left is actually vertical lines. If you draw a vertical line, I showed you how to draw a vertical line before. Vertical line, you can say right and left side of vertical line. But all the other three, horizontal, positive slope, negative slope, we will have to say above and below. All right. So check this out. If I ask you what is this inequality, let me move this stuff down a little bit. If I ask you what is this inequality, a lot of students say this is less than. Well, it's true if you read it from the left side. Okay, so since we've been solving for y, so that means our variable that we were solving here in a bit will be y. So if you read, so if the variable y is on the left side, if you say y is less than means below the line, okay, or to the left for the vertical. Now, if the variable is on the right-hand side and the inequality goes this way, read from the variable, this is also saying y is less than. Okay, you read from the variable. Less than means below the line are the visible region where all the coordinates below that line satisfy your inequality. All right. So if I was say y is greater than means we will actually shade above the line because every single coordinate above the line is going to satisfy my inequality. All right. If the variable is on the right hand side, so it look like this, y is what? Greater than. Okay, be very careful. Okay, a lot of times when you just wrote that inequality, this is not always less than. It depends on which side you're reading from. Okay, so for now we're gonna read from the side where the variable is. Then that will determine. Then that will tell us where are the coordinates points that will satisfy the inequality. All right, so I build these questions kind of guide you to it. All right, so we only draw one line here. Consider the following linear inequality. So I'm using inequality sign rather than equal sign. Write the linear inequality in the slope-intercept form, and we're gonna state its slope and its y-intercept. So again, solving for y, that's what we've been doing. Number one, negative 5x plus y greater than equal to negative 3. All right, right now, if I want to solve for y, my variable term is positive. If it's positive, let it stay. I'm going to move my negative 5x to the other side of the inequality. Now, my inequality should say y is what? If you read from the variable y, this is y is greater than equal to positive 5x minus 3. My slope m got to be 5. 5 means 5 over 1. And my y-intercept, 0, comma, negative 3. All right. So number 2 says, reading from the variable y, the inequality says what? If you read from the variable y is what? Greater than or equal to. That's what you type on the homework and on the test. All right. So when you say greater than or equal to, you got to use solid lines. When you say greater than or equal to, the word greater means our visible region will be above the line I'm going to draw. All right, so use the slope and the y-intercept to graph the linear inequality and shade the visible region. So this part we got to do it on by hand. All right, so starting from my y-intercept, 0, negative 3, 1, 2, 3. I'm going to use my slope to go to my next point. My slope tells me to go up 5 to the right 1. Up 1, 2, 3, 4, 5 to the right 1. Because my inequality has that equal to, I will use a solid line. All right, so this line apparently is going up the hill. So use a highlighter. This line is going up the hill. So when you say greater than, that means every single coordinates above this line. Okay, don't say right and left. Say above and below. So if I put myself on the left side here, that means I'm going upward, right? So the side where I'm at, that side is actually above. So every single coordinates on this side of the graph is actually above. So that's my visible region. This is my solution region. Now there are a lot of application problems involving with inequalities. If we actually dealing with two variables, okay, which means if we can draw two lines, okay, and involving with inequality, there's actually a lot of application actually dealing with those. But right now we're just drawing one line and see where are the coordinates that will satisfy the inequality. So if you pick any point right here and plug into the original equation for x and y, the answer coming out will always be greater than or equal to negative 3. Okay, that's what we're doing here. All right, let's try another one. Okay, it's nothing hard. What we're looking for here is a whole entire region of coordinates that will satisfy this entire inequality. All right, so same thing, solving for y. So number 1. All right, my linear inequality is 2x minus y greater than 5. So since my variable term is negative, I'm going to move it to the other side. So that means the 5 will come over. All right, so inequality states like that, okay? Negative y to the right side become positive. 2x still 2x. Positive 5 come over, become negative. So my slope m got to be 2 over 1. My y-intercept got to be 0 comma negative 5. All right. So if you, number 2, if you read from the variable y is what? This inequality says y is what? Got to be what? Less than. Less than means we will shade below the line. Less than means we will also use dash line as well. Dash line simply means the coordinates on the line itself does not satisfy the inequality. That's the only difference between solid and dash. So let me go to my y-intercept, 0 comma negative 5. And I'm going to use my slope up to the right 1 to find the next point. So this time I will use dash lines. And I'm going to connect them real quick. All right. So this, again, this line is going up the hill. So again, if I put myself on the left side, okay, the side where I'm at is the side where I'm at is above it. But since it says less than means we'll shade below. So where is below this line? Well, right underneath you. So that will be every single coordinates here below this line. All right, that will satisfy this inequality. So this entire region is called the solution region, or I call the feasible region. Okay, that's all it is. All right, make sure you use a highlighter, okay? Make sure you use highlighter, because highlighter I can read a little bit better. All right, let's try another one, okay? One last one. Again, same thing, okay? So this is the second time I'm gonna show you, all right, my variable term is negative. So if the variable term is negative, then I'm gonna move it to the other side. Bring the 16 over. So my inequality is still this, okay? Negative 4y come to the right, become positive 4y. 3x is 3x, positive 16 come to the left side, become negative. To get y by itself, divide every term by 4. So now my y will be what? So if you read from the y, this is y greater than 3 over 4x minus 4. So number 2 is actually saying greater than. Greater than means in a minute, we're going to shade above. Because there's no equal to, I will use dash lines. Slope m, 3 over 4, y-intercept. So write all this down for me. Y-intercept, 0 comma negative 4. All right, 0, negative 4, right? Go down 4. All right, use my slope to go to the next point from the y-intercept up 3, 1, 2, 3 to the right 4. There will be that point right there. This time we will use dash lines. There we go. All right, so since it says y is greater than means above the line, all right? So do not go by the original inequality. Go by the inequality after you solve for y. So if I put myself on the left side, okay, the side where I'm at going up the hill, the side where I'm at is above it. So that's the side I'm going to shade, because when I read from the variable y, it says y is greater than. All right, so just real quick, showing you how to graph linear inequality. so we can find its visible region. That simply means it's a region of coordinates or points that will satisfy the entire inequality. Okay, all right, that will conclude this video. Thank you for watching.